Well, dear students, we are doing more questions on application of derivatives. And by now, we have completed tangents and normals, increasing and decreasing functions. And now we have been doing that maxima and minima. So one most important question we will be taking and try to understand the concepts, the procedure and the steps, how to begin with, how to think, and how to arrive at a result of this kind of questions. The questions taken as prove that the volume of the largest cone, this is the question from NCERT textbook, exercise 6.5, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 upon 27 of the volume of the sphere. That means a cone is inscribed in a sphere. Okay, the capital R being the radius of the sphere, and that the cone will have a base radius that will be taken as a small r, and this part, this part will take it as x. Okay, let r be the radius and small r be the base radius of the cone, and this part, as I said, OD will be taken as x, and then this is a right angle triangle. You can see in this right angle triangle the Pythagoras relationship we will be using. Capital R square is R square plus X square, therefore R square is nothing but R square minus X square. Volume of cone 1/3 pi R square H, and H means height of the cone. Height of the cone is RD, AD, AO plus OD, that is R plus X. Height H, R plus X. R square, we have calculated this, 1/3 pi R. So volume will be, this is better to multiply before going for the differentiation. Otherwise, you need to put U into V, product rule. No problem. But this is the easier way of, I think, that is why I multiplied. Then dV by dx will be pi upon 3. This is being constant, 0. This is R square. Okay. And this is minus 2xr. And minus 3x square. Whatever differentiation, then putting dv by dx equal to 0, we will be calculating the value of, by splitting the middle term, we calculate the value of x in terms of r. So this is not valid because their lengths cannot be negative, and x will be r upon 3. Then we will go for second derivative, and on second derivative test we will be putting x as r upon 3. Then you will definitely get, this is a negative value. यहाँ पे अगर r upon 3 हम रखते हैं, है ना, so r upon 3 रखेंगे तो minus 4r, 4 pi r upon 3 is a negative value. Once it is negative, that means it is a point of local maxima. Now the volume of the cone, so that is a point of maxima. So volume of the cone we will put here x. We'll put here x as r upon 3. Then we are calculating this. Take the LCM and calculate. And then you are getting 8 upon 27, 4/3 pi r cube. And this is nothing but volume of the sphere. So 8 upon 27 volume of the sphere. This is the way of attempting these kind of questions. I will be assigning 2 more questions. Okay. So a wire will be cut into 2 pieces. One is made into a square, another made into a circle. Then how to find the minimum combined area. Application of derivatives. Very, very profound questions are there. A rectangular sheet is given. You will cut in square pieces from 4 corners, and then we will make a open box, and then finding, and so that the volume of the box is minimum. That means when you go for dv by dx, d square by dx square, the second order derivative, that will come here positive. So because volume is minimum, here also it will come. So we'll take length, breadth, and x cut kiya, length, breadth, and height. Volume will be length into breadth into height. Calculated dv by dx on putting dv by. Procedure will be same. You will do this. You will really enjoy. That is why I have assigned these kind of questions. So enjoy mathematics. Thank you.